Welcome to qnawire.
The nuclear binding energy is the energy that's involved when the particles, the protons and neutrons, come together to form a nucleus. And this binding energy has to do with the fact that some mass in the process is converted into energy. This delta M is called the mass defect. And it's the difference in mass of the nucleus and the sum of the parts of the protons and neutrons, or the nuclides. Because you would expect that if you added together the protons and neutrons, it should be equal, but we see there's slightly difference in that. So that's called the mass defect. So to find the mass defect, we know for lithium-7 that lithium-7 is made up of 3 protons and 4 neutrons. 3 protons because that's the atomic number, and 4 neutrons because that's the mass number minus the atomic number. So to find my mass defect, I multiply the mass of a proton times 3, plus 4 times the mass of a neutron, and then I subtract from it the actual mass of the nucleus. So the mass of a proton is 1.007825 atomic mass units. And the mass of a neutron is 1.008665 atomic mass units. And we know the actual mass of our nucleus is 7.016003 AMU. So in this case, the mass defect is equal to 0.042132 AMU. Convert that to energy. A relationship that relates the change in mass to energy is that for every 1 atomic mass unit, 931.5 mega electron volts is produced. So if we had 0.042132 atomic mass units, we can change that to electron volts. Knowing that there are 10 to the 6 electron volts for every 1 mega electron volt. And so the energy released in electron volts per nucleus is 3.92 times 10 to the 7 electron volts. If we want to compare that on a different level, we can change our value to kilojoules per mole. We have this many electron volts per nucleus. We know that there are 6.02 times 10 to the 23rd nuclei per mole. So that tells us in electron volts how much energy there is per mole. And then a relationship that we can use is that there's 1.6022 times 10 to the minus 19 joules for every electron volt. And then finally, there are 1,000 joules for every kilojoule. So by multiplying the top numbers and dividing by 1,000, this gives us our final energy, 3,785 kilojoules per mole. Nuclear binding energy can be found in either electron volts per nucleus level or on a macroscopic level, kilojoules per mole.